Okay, so Sally's Sweet Shops uses the logo of a wrap sweet in all its merchandise. Find the area of the logo, the shade area in the diagram. Okay, so what we're going to first do is we're going to look at the two different curves. Okay, so what I'm looking at here is the red curve. Now I'm going to find out what this area 1 is here, okay, or area A I'll call it. So this here is area A. Area A is pinned into the x-axis, so I'm going to use BA y dx. Now the b value is 3 to 1 y dx. So this is the this curve here, or sorry, the u-shaped curve which I'll be using. So it's this curve here is the equation I'm using. So it's going to be x squared minus 4x plus 3. Okay, so I'm using this u-shaped curve here to find out what area A is. Okay, now once I find out what area A is, I'm just going to put this in the corner here. So this here is area A. Okay, so now I'm going to find out what area. We'll find out what area B is. Okay, so area B, just this one here, is the area between the x-axis and the x-axis and the n-shaped graph, which is this function here. So it's going to be from 1 to 0, integrate minus x squared plus 6x minus 5 dx. Okay, and that's the next part. Now what we got to find after this is we're going to have to find out what is the area of this region in here. So if I was to take this part here away, so we've done area A and area B, so what I need to do is I need to find out what is the area here, and then so we call this area C. So you're going to find out what area C is, and to find out area C, what we're going to do is the integral of 4 to 1, and it's the n-shaped graph, so it's going to be minus x squared plus 6x minus 5 dx. Now the problem here is I've added in an extra amount and I need to take it away. So this little area here, which I'll colour in purple, is going to be the area. We'll call that area C, we'll call this area D. So we've got to take away area D. Okay, and area D is going to be the integral from 3 to 4, and remember it's the u-shaped graph this time, so it's going to be x squared minus 4x plus 3 dx. Okay, that's the next one. And then finally, what we're going to have to do next is we're going to have to figure out what is this area here. So we have two separate sums here. Now one thing we got to also remember about area A, area A is going to be negative, so we got to take its absolute value, its positive value. Okay, this is area C minus area D, which is its own sum as well. And finally, to find out what is the area of this region here, which we will now call area E. Area E is basically going to be area E, well we'll rename area E. We're going to get the area of all this here to be area E. So area E is going to be the integral of it's the u-shaped graph, so it's going to be x squared minus 4x plus 3, and that's going to be from 5 to 4. Okay, and that's it dx as well. But the problem is we also double counted a square. So this square here is going to have to get taken away from it. Well, the square is 1 across. Now I could really do with finding out what this intersection point is. So to get the intersection point is when both curves equal each other. So I'm going to get x squared minus 4x plus 3 and that's going to be equal to minus x squared plus 6x minus 5. I'm going to bring everything over to one side. I'm going to get 2x squared minus 10x, and then minus 5 goes over to the other side to make it 8. Reference number here is going to be 16. 16 has 8 and 2, so it's going to be 2x squared minus 8x minus 2x plus 8 equals 0. Then we're going to get 2x into x minus 4 minus 2 into x minus 4 equals 0. Then we're going to get 2x minus 2 bracket x minus 4 equals 0. And then I'm going to get 2x minus 2 equals 0. So x is going to equal 1, or x equals 4. So this point here is 1 and 4. So we already knew that. Okay. So actually that sort of proved to be completely pointless, but just shows you can get it if you want, if you weren't given it in an exam. So what I need to do is I need to find out the height, the y value. So when x equals 4, the y value is going to be 4 squared minus 4 times 4 plus 3, and that's going to be 16 minus 16 plus 3. It's going to be 3. So this rectangle here is 1 across and 3 up, which is an area of 3. So we need to take away an area of 3 from that part. So what we've done is we've divided up question 26 into 3 different sums. Okay, so now it's in 3 different sums. Let's do each one individually. Okay, so what we'll do first and foremost is we'll take these two further down and leave them till later. Okay, and now let's see what we're getting here. So we're going to integrate this, and we're going to get is a third x cubed minus 2x squared plus 3x, that's all from 3 to 1, plus the integral of, that's going to be minus x squared, so it's going to be minus a third x cubed plus 3x squared minus 5x from 1 to 0. And we're going to have to add the two of these together. So we're going to get the first one. It's going to be a third 3 cubed minus 2 times 3 squared plus 3 times 3. Take away. Now I'm just going to do this part here. Okay, so it's going to be take away a third 1 cubed minus 2 times 1, sorry, all in brackets, plus 3 times 1. So we're going to get here is going to be 9 minus 18 plus 9. I think. And then the next part after that is going to be minus a third minus 2 plus 3. All of these cancel, and then you're going to be left with minus you're going to be left with minus 2 plus 3 is plus 1, so you're going, and 1 is going to be 3/3, so you're going to be left with minus 4 over 3, a negative area as we suspected. So this area here is 4 over 3. So I'm just going to rub out all these workings here a second ago, and all we're going to do underneath this is say that that area there is 4 over 3. Okay, so this area here is 4 over 3. Now we're working with area B, which is this part here, blue. So we're expecting a similar size area. So let's integrate this one this time. So it's going to be minus a third times 1 cubed plus 3 times 1 squared minus 5 times 1, close bracket, from 1 to 0. Oh yeah, and sorry, the second one would be take away all the zeros, but because 0 is in every 1, it's just going to be 0, 0 and 0, because we're replacing x with 0, so that's no point there in doing that. Then we're going to do this out, and we're going to get minus a third plus 3 minus 5. Okay, and once again we're expecting a negative area in here because it's below the x-axis. So once again we're going to have to use the modulus sign on this. We're going to get minus 2 minus a third, which is going to be minus 7 over 3. So because we have to get the modulus sign, that's going to turn out to be 7 over 3. So area B, which is this area here, is now 7 over 3. So 4 over 3 plus 7 over 3 is the first bit. Now we're down to this part here. Once again, just going to extend the page here, and we're going to look at this part here. What exactly are we doing with this part here? Now, this part here is integrating 4 to 1 of minus x squared plus 6x minus 5. 4 to 1. So 4 to 1, as we said earlier, is we're going to be just integrating here to here, and it's going to be this full yellow shaded region here. Okay, so that's what we're doing first, getting the area of this yellow region. Now we're expecting a bigger number than 7 over 3 and 4 over 3 that we got earlier. So let's see if we're correct. Okay, so integrate, and what we're going to get just for this part here only, okay, is going to be minus a third x cubed plus 3x squared minus 5x integral of 4 to 1. Let's put in the 4's and the 1, so we're going to get minus a third 4 cubed plus 3 times 4 squared minus 5 times 4. I'll take away minus a third 1 cubed. Now we're expecting a positive number this time for the answer, plus 3 times 1 squared minus 5 times 1, close all the brackets. So we're going to get is minus 64 over 3 plus 48 minus 20 minus bracket. We're going to go for minus a third there plus 3 and minus 5. Now that we have all the hard work done, we might as well just put this into the calculator. We get minus 64 divided by 3 plus 48 minus 20, just press the equal sign there, that's 20 over 3. 20 over 3 is going to take away, what are we going to take away from that? We're going to take away minus a third. So we're going to get minus 1 all over 3 plus 3 minus 5. Close bracket again, and we get the answer for that is 9. Okay, so the full answer to this question here is 9. So once again we can rub this out and we can say the integral of all of this is 9. Okay, so we have a 9 here. Now was 9 something we're expecting? It's a much bigger area than what we've been dealing with, so yeah, 9 would have been in the ballpark of maybe what we're expecting. Now we've got to take away this area in here, which we'll shade in green. So this area in here has been double counted and we need to take it away. So this is where this one comes out. So once again we're going to integrate, and we're going to get a third x cubed minus 2x squared plus 3x from 4 to 3. Integrate it, you're going to get a third 4 cubed minus 2 times 4 squared plus 3 times 4. Take away a third 3 cubed minus 2 times 3 squared plus 3 times 3. Okay, integrate this, we're going to get 64 over 3 minus 32 plus 12. Then we're going to take away a third of 27. So that's 27, and a third of that is going to be 9 minus 18 plus 9. Okay, we should probably use this on the calculator now. So that's going to be 64 over 3 64 over 3 minus 32 plus 12 minus, now bracket 9 minus bracket 9 minus 18 plus 9, which has actually turned out to be 0 in the end anyway. Now, what we got there was minus 239 over 3. So we're just going to double check this answer again. It's not what we're expecting. So we have 9 plus 9 minus 18 all cancels. And what we were looking at there was maybe 64 minus 32 plus 12. So we just need to, it's not a 90. There's your problem there. So if we press equals here, we got 4 over 3 for that. And 4 over 3 is a small area, exactly what we're looking at for the area. So it's going to be 4 over 3. Now, this part here, therefore turns out to be 4 over 3. Now we're told that we had to take them away from each other, so it's going to be 9 minus 4 over 3. So then we have 9 minus bracket 4 over 3. And we get here is 23 over 3. So 23 over 3 is the answer to this part here. Okay, so this area in here is 23 over 3. The area of part 1 was 4 over 3. This part here is 7 over 3. And now finally we're on this one here. That's what we need to find out now. So as I said before, what we're going to do is we're going to integrate the full thing, although including this part here, and then we're going to take away what's in the square, which is 3. That's what we determined earlier. Or not the square, but the rectangle. So let's integrate this. So we integrate a third x cubed minus 2x squared plus 3x from 5 to 4. And then what we're going to get here is going to be a third. Now we might as well just put in the numbers now. So it's going to be a third. This is going to be 125 because 5 cubes is 125. 5 squared is 25. 2 times 25 is minus 50 plus 15. Take away 4 cubed 64 over 3 minus 4 squared 16 minus 2 minus 32. 3 times 4 is 12. Now take away all this in the calculator. So what we're going to get is 125 all over 3 minus 50 plus 15, 20 over 3. So we got 20 over 3 for that part. Now we're going to take away the other part. So minus what's in here, 64 over 3, and minus 32, and plus 12. Close bracket, and we get 16 over 3 as our overall answer. So that must have made that part 4 over 3. Now, this 16 over 3 that we're talking about. Okay, so this 16 over 3, we bring it all the way back up here. We got to take away 3 from it. Take away 3. So taking away 9 over 3, which is going to be leaving us 7 over 3 for this part here. Now finally we've got to add them all together. So what we have is a 7 over 3. 7 over 3 plus 4 over 3 plus 23 over 3 plus another 7 over 3. That will give us 41 all over 3. Okay, so 41 all over 3 is the answer, and that's the answer in the back of the book. 41 divided by 3.